Today's assignment is on independent probability. It is very, very similar to last week's compound probability. And so I've started by writing that note on the top left to review that, remember, we need to multiply separate events together for and. So if we want this and this and this to happen, we multiply those probabilities together. Now, there is a new difference to this one. This one is slightly more complex than the last one. Our probabilities sometimes have different numbers. So it's not like that coin that was repeated half, half, half again, but sometimes it's like a coin in a six-sided dice. So it's some number out of 2 and some number out of 6. And you also need to keep in mind that the wording on this one has changed. It's not always just that one outcome, but sometimes it's a range of outcomes that they're looking for. And there's one last note that we need to make, which is this not thing. So the probability of something happening and the probability of something not happening, so happens and not happens, is always going to be 100%, because so that means that together, if something happens or if something doesn't happen, that accounts for all of our probability, all of our possible outcomes. So in this case, that means that if you know the probability that something happens, if you know that number, the probability of something not happening is always going to be a 1 minus the probability that it happens. And the 1 in this case is going to be for 100%. And that's used immediately in this example. So let's look at this example now so I can show you how this is going to play out. This says that some dude is making or missing free throws, and that the probability for each one of these is independent. That means that each time he throws one, he's got the same chance as the one before it. Making one doesn't automatically put him on a hot streak or anything like that. And it says that he makes 3 free throws 82% of the time. So that means that the chance of something happening, the chance that he makes this free throw happens 82% of the time. So that means that the chance that he does not make it means that's going to be a 1 minus 0.82. So I've changed this to decimal form. This could also be represented as 100% taking away the 82% that he made it. So the chance that something does not happen is 1 minus 0.82, or 100% minus the 82%. So if the chance that he makes it is 82, the chance that he does not make it is 1 take away the 82. So it's whatever space is left in that 100% after we take away the number that he would make, the percentage that he would make. All right, so the actual question here, so now we've got from our setup, our data, we know that the chance that it happens is 82, the chance that it does not happen is at 1 minus 0.82. The question here says, what is the probability that dude is making none of his next 5? So this says making none. That means we want the chance that he does not make this. And remember over here that and means multiply. So that means we have a chance of not making it 5 times. So as I'm looking at these answer choices, I'm seeing this 1 minus 0.82 a couple of places. One says to the power of 5 and one says 5 times that. And I did say 5 times, so you might be tempted to choose C, but that would be wrong, because this and means multiply. It's not the number of times we're multiplying it together, it's the probabilities that we're multiplying together. So that means I've got a 1 minus 0.82 for the first shot of not making it, and a 1 minus 0.82 for the second time not making it, and a 1 minus 0.82 for the third time of not making it. 1 minus 0.82 means that he doesn't make it a 4th time, and 1 minus 0.82 means he doesn't make it a 5th time. So simplified, our correct answer is going to be answer choice A here. That says 1 minus 0.82 for 5 individual throws. All of those probabilities multiplied together is to the power of 5, not multiplied by a value of 5. All right, so here is a second example out of your problem set. It says Captain Gabriella has a ship that is 2 furlongs from the dread pirate Amos and his merciless band of thieves. So the captain has a probability of 1/3 or 3 has a probability of 3/4 for hitting the ship, and the pirate only has 1 good eye, so he hits the captain's ship with a probability of 1/4. So let's organize this information real quick. I've got a captain and I've got a pirate. To hit, the captain is 3 out of 4, and the pirate is 1 out of 4. Now, to miss, remember, this is whatever's left in that chance space. So if 3 out of 4 times he hits, that whatever's left, that 1 out of 4 is whatever they miss. So 3 out of 4 hits means 1 out of 4 is what's left to miss. And the pirate's going to be the opposite. If he only hits 1 out of 4 times, then that means he missed the other 3 out of the 4 times. All right, so we've got all of our information for our setup that told us what 2 people were going to be involved. We've got our data set up from how much they're going to hit. So now let's look at our question. Our question asks, if both fire their cannons at the same time, what is the probability that the pirate hits the captain's ship, but the captain's ship misses? Okay, so the pirate needs to hit, so that's 1 out of 4. The captain misses, that's also 1 out of 4. These are both an and again, so 1 out of 4 for the pirate ship hitting, coupled with and a 1 out of 4 for the captain's ship missing. Multiply straight across. 1 times 1 is 1. 4 times 4 is 16. So our correct answer for this example is 1 out of 16. One last blurb, not tied specifically to any one of these problems, but I did see it in the problem set. That is the phrase "at least." So let's say, what's the chance that you roll a 6-sided dice, so 1 through 6, and get at least a 5? And this at least is going to change what outcomes we're looking for. You see, to be at least 5, that means we could roll a 5, or we could get a 6. So out of our 1, 2, 3, 4, 5, 6, the possibilities for rolling a dice, at least a 5 is a 5 or a 6. So that means that probability-wise, this is 2 outcomes that we would like for at least 5, that's 5 or 6, out of the total of 6 that were rolled for the dice. So please watch out for the at least or less or more than, because those range of numbers does mean we're going to have to count up. So back to our simple probability idea, our ideas of each individual thing happening, please again watch out for those extra words that may be in those questions, which means that this problem set is slightly more difficult than the last because you will need to read more carefully.